Hello, everyone. Again, today, just so you know, we expect to spend about the next 30 minutes or so kind of walking through the Blues ecosystem, what we're about, the problems we're helping to solve in this world of wireless connectivity, and how we specifically help to solve them. Quick introductions before we get started. My name is Rob Lauer, and I'm Director of Developer Relations here at Blues. But more importantly, with me today is TJ Van Tol. TJ is going to provide a brief demo on setting up a Blues starter kit and sending your first data to the cloud via cellular, Wi-Fi, LoRa, probably not satellite, but satellite is an option. We'll see how things go today. So in our very limited time, we do have a pretty simple agenda. I'm going to start by giving a brief overview of Blues, the Notecard and Notehub, and then TJ is going to provide more of a hands-on demonstration of how it all works together. Now, as you have questions as they come up today, please enter them in the Q&A panel provided. After we are done talking at you, we will take some time at the end to answer as many questions as we possibly can, given our time constraints. So let's get started. So this is the star of our show today. This is the Blues Notecard. Notecard itself is a system on module. What does that mean? Well, it contains a radio and components and circuitry, all to make it function as a standalone wireless connectivity module. And it's very tiny as well. This is our largest one, and it measures 30 by 42 millimeters, making it pretty easy to embed in almost any product. And TJ's holding one up there. Now, what does Notecard do? Well, it adds cloud connectivity to your physical product. I really like to think of it as occupying this middle space, this boring space, right? The cloud, the part of cloud enablement that you don't want to deal with, right? You want to build your product, you want to build your cloud application or use your IoT platform, but we provide that seamless bidirectional data flow between the two. Now, if that's what Blues is doing today, I do think it's also important to ask ourselves what people had to do yesterday, right? What legacy problem is Blues actually solving? Well, historically, they built a bespoke or DIY wireless communication system, which requires what? Sourcing and wiring hardware from bare modems to supporting components. You're writing the firmware to manage the radios, managing cellular connectivity, tower handoffs, definitely not trivial. You're building a secure cloud infrastructure to reliably sync data. And again, like none of these are really trivia here. Or you choose Blues and you can focus on your core competencies and not like effectively have to reinvent yourself as an IoT company, just to get your product connected. And to be clear, as an engineer at heart, I'm not here to spread fear or anything, as there are certainly companies who have done this manually successfully, but Blues is just here to dramatically simplify this for you. So I like to think of Blues as making wireless IoT easy for developers and more affordable for all. So how do we actually make that happen? Well, we do have a strong focus on securing your data from the moment it's acquired by a sensor all the way through to landing on your cloud application of choice. Also, all of our hardware solutions are low power out of the box. They go down as low as 8 microamps when idle for the cellular note card. We are also a developer-focused company, so our developer experience is a top priority for us, and you'll see that kind of play out in our elegant and really easy-to-use JSON-based APIs. And finally, you'll hear a term called wireless harmonization from Blues. Now, that means all of our hardware is swappable, both in terms of the physical connectors we use, but also the developer APIs. So literally with Blues, you can build with Wi-Fi and then deploy with cellular or deploy with LoRa, or even have different radio access technologies in the field, all using the same firmware code base. So that this last point is really super critical for us, because in this magical world of wireless harmonization, choosing that radio can and should be a deployment time decision instead of a development one, right? So you can develop a solution, and then when it comes time to deploy, then make that choice of cellular, Wi-Fi, LoRa, maybe satellite backup, all based on the specific needs of the actual destination you are deploying to. All right, so let's zoom in on the note card itself a little bit more. The note card, again, is the kind of the core hardware product we provide. During my time at Blues, I feel like I've learned a few things that people get really excited about when it comes to the note card. First is that our cellular note card provides global cellular reach. It also ships prepaid with 500 megabytes of data and 10 years of service. There's no monthly SIM fees. So if your product sits on the shelf for 3 months, it doesn't cost you anything. You can literally connect your product to your cloud with 2 lines of code, and TJ will show that off. It's also built to be low power, consuming 8 to 18 microamps when idle, depending on the radio in use. Now, as mentioned, there's plenty of note card options depending on that radio that you need or want to use. They are all swappable, both in terms of the physical connector and the APIs. So again, let me run through them quickly here. We have a whole line of cellular only note cards. We have Wi-Fi only note cards, LoRa only, and the LoRa ones come in US and EU variants. There is a cell plus Wi-Fi, meaning you can use Wi-Fi if you want to, or cellular, or use a Wi-Fi to cellular fallback capability if Wi-Fi goes down. And then there's a satellite option called StarNote that provides fallback connectivity from cellular or Wi-Fi to satellite in supported regions. Now, what do developers get excited about when you talk about all of these note cards? Well, I mentioned this earlier, but you are using one API the exact same way to program all note cards. Again, your core competencies here, right? You don't want to spend 6 months learning the intricacies of LoRa when you just want to get your device connected, and that's what we're here to offer. Now, to make it easier to use your note card when you're in the prototyping phase, or even some people use these when they are embedding in a more permanent solution or when they're scaling in production, we provide these open source development boards called Notecarriers. These are development boards that let you swap in a note card and connect it to really any solution you can dream up. Let me run through them really quickly here. So the Notecarrier F comes in our starter kit. This includes a feather compatible socket at the bottom there. The A model includes onboard antennas from Ignion. There's also a row of headers there that let you hook it up to basically any microcontroller you want. The Notecarrier X is a line of small form factor note carriers. And the Notecarrier Pi is a Pi hat for working with any Raspberry Pi compatible single board computer. And our partners SparkFun and Rack Wireless both have designed note carriers for their specific ecosystem. So on the SparkFun side, they have their Micromod ecosystem, and Rack has their Blues.1, which fits into their WISP-Block ecosystem. All right. And yes, I already mentioned this, but there are here are those two lines of JSON needed to cloud connect a product with Notecard. You send these over USB, UART, or I2C, and yes, it is the same commands for all note cards, regardless of the radio in use. So how are you or your developers really programming the note card, though? They probably are not hand coding JSON, but rather using one of our supported SDKs for virtually every and any popular language in RTOS. The ones in the top row are supported by Blues directly. The ones in the bottom row are community supported that we also offer some support for as well. Okay, with all that, let's move to the cloud now, because at Blues, the note card is really only half the story. The other half is our cloud service that we call Notehub. And the two work together to form what we call a device to cloud data pump. In practice, what that means is a developer is going to buy a starter kit. They're going to hook up a sensor to it and start reading data with the host MCU and deliver that data securely over cellular to Notehub. And Notehub is going to route that data to your cloud. So to be crystal clear here, Notehub is a cloud service, but we're not trying to create a platform that locks you in. We exist really to help you connect to your platform, be it AWS, Azure, Google Cloud, whatever it is. We're really trying to help solve this messy middle piece of connectivity so that you can easily and securely connect your device to your cloud. So some quick Notehub details as well. The most important thing to know about Notehub, it is a secure proxy that allows the note card to communicate with the cloud. Notehub takes care of all the security considerations and cloud connectivity for you. Part of that savings comes from routes. Notehub lets you route note card data to any cloud app. And within Notehub, you can manage fleets of devices. You can update both host microcontroller and note card firmware over the air. And when I talk about security, data is transferred off the public internet between Notecard and Notehub via private VPN tunnels, can optionally be encrypted as well. There's no certificate management or key rotation required. The Notecard knows exactly where to go as soon as it is turned on, which makes it a really powerful, really convenient tool to use. So that's much of what Blues brings to the table. But just as importantly, though, you should know what you don't need when you choose Blues. You don't need your own SIM or mobile plan. As I mentioned earlier, Notecard comes with an embedded SIM with global support. Likewise, to work with that cellular radio, you're not issuing AT commands, you're not managing cellular connections manually, it's just JSON-based API calls. You're not rolling your own security. Notecard includes an integrated ST-safe secure element with hardware crypto, a hardware random number generator, and a factory installed certificate that's all provisioned at chip manufacturer. Now, for firmware updates, the Notecard and Notehub together provide incredibly easy ways to update. I mentioned this previously, but updating both Notecard and ESP32, STM32, or NRF host firmware, so you're not creating your own custom process to do that. And of course, while there's always some type of power management involved, all the components on the Notecard are low power by default, as are the default configs in the Notecard's firmware. And as you'll see today, securely sending data to your cloud endpoint, it's baked in, it's remarkably simple. And lastly, the Notecard is FCC and PTCRB end product certified. So in some, not all, but in some cases, you don't have to acquire separate certification for your product when using the Notecard. Obviously, that's going to vary a lot depending on what you're actually building. Now, finally, to help kind of visualize everything I really threw at you there in the last 10 minutes, let's kind of help wrap this up and show you where and how Notecard and Notehub sit in a given IoT solution. You're going to bring your microcontroller, right? Or your single board computer. You're going to use your sensors, your programming language. We're not dictating any of this for you. You're going to compose packets of JSON data that we call notes. These notes or these events are going to be stored. They're going to be queued on the note card. Then at a cadence you specify, they will be securely synced with Notehub. Now, we don't want your data to live on Notehub. We want you to route that data out to your cloud application of choice. Again, meaning a big cloud, or maybe it's an IoT provider like an Ubidots, a Losant, a Datacake, whatever it may be. And it's important to note that communication with the Notecard is bi-directional, so you can actually start on your cloud application. You can send a JSON-based request to Notehub using the Notehub APIs that we provide, and Notehub will securely deliver that JSON payload to a note card or maybe to a fleet of note cards. The note card will then intelligently deliver it back to the host. So you can see here, you can easily handle, remote control scenarios or updating fleet variables all remotely, all securely, over whatever radio that you want to use. Now, with that kind of summary I threw at you here, it's probably time to see some of this in action. So let me hand the controls back over to TJ.
Yeah, and what I'm going to do is I always like to start by just showing the hardware. I think it's one thing to see it in a slide that Rob has, but I think it's another thing just to see what the hardware looks like sitting on my desk. I'm going to give you a brief tour. If you have any questions, if there's anything you want to see in more detail, let me know and I can focus on just one piece of hardware. But in short, these four here are our different types of note cards. We've got a Cell Plus Wi-Fi note card. This is a note card Wi-Fi, a note card Cellular, and then a note card for LoRa. The thing to notice again is that they all share the same form factor, the same M2 edge connector there on the bottom. And then our open source development boards, our Notecarriers, I kind of have scattered around the different note cards. You'll see that in general, all of them have that same M2 connector, so they all make it easy to slot in a note card and then provide different development conveniences depending on the board you're interested in using. The X series are kind of our minimal note carriers, so really all these provide is just a way to slot in the note card, expose the pins from the note card, provide power through like a LiPo battery or USB. From there, the A has onboard antennas from Ignion. This is red ones here on the side and on top. Our F comes with our Cell Plus Wi-Fi starter kit, and it gives you a way to plug in a Feather-compatible microcontroller and provides all the wiring so that the microcontroller can talk to the note card out of the box, and we'll look at that in a second. And then finally, the Note Carrier Pi. This is designed with the 40-pin Pi header so that you could just slot this right on top of a Pi and provide cellular connectivity for that ecosystem. And then the last bit here is our Star Note. So this is a Star Note. We have two different variations of it, one with onboard antennas and one with these UFL connectors for attaching an external antenna. And then we also provide the Note Carrier XS board. And this accepts both a Star Note and a note card and does all the wiring. So you can just plug in the two of those and build a product that uses cellular or Wi-Fi and that has a satellite backup. So a lot of stuff here. It can be fairly overwhelming. When you're first starting with Blues, and I'm going to bring up the website here in a second, we recommend starting with one of our starter kits. And the easiest one to start with is our starter kit for Cell Plus Wi-Fi. That's going to come with a note card Cell Plus Wi-Fi, a Note Carrier F, and then also a Feather-compatible microcontroller we make here at Blues called the Swan, that if I can hold it in the camera here correctly. You can use any microcontroller in our ecosystem. This is one of those things we're not trying to dictate for you, but in our starter kits, we like to provide one so you have a smooth getting started experience. And what I'm going to do from here, so I am going to switch my camera over to me, and then I'm going to bring up my screen as well. Because what I want to show is what that getting started experience looks like. So as I mentioned, when you start with Blues, we recommend going with one of our starter kits. That's the main call to action on our developer site, blues.dev. And you'll see that we have several different starter kits, but again, recommend starting with the starter kit for Cell plus Wi-Fi. So once you have that hardware, you can go to our docs and get started, and this link here to get started. And we have a series of tutorials in place for all of our starter kits. For the Cell plus Wi-Fi one, the getting started flow is 4 different steps. We'll teach you how to use your Notecard, how to set up the Swan microcontroller that we include in the starter kits, how to put everything together and to build an actual app, and then how to take your data and route it someplace that you ultimately want it to end up. So I don't have time to go through each and every one of these tutorials. What I'm going to do today is go through this first tutorial with you so you can see what using the Notecard looks like. And then I'll skip ahead and show you kind of the end state of this so you can get a broader picture of what building an actual app with Blues really looks like. So I'm going to start this Notecard Quickstart. And you'll see that for the most part, this looks like any other tutorial you'd find online for any sort of software, hardware-based product, except you see this panel here on the right-hand side of the screen. On our docs, we have a pretty cool feature where we leverage what's the Web Serial API. It's an API that's built into Chromium-based browsers like Google Chrome and Microsoft Edge that allows you to perform serial connections with a device through a web browser. So what that means is you'll see in this tutorial here in a second, it's going to say to connect via USB. So I've already got a note card here set up that I'll hold up where I've got a note card connected to a note carrier. In this case, it's the X, but really you can go through this tutorial with any note carrier and my antenna attached. And then I've got a USB connection to my laptop. And what that's going to let me do is just click this button here to make a USB connection with my note card. And the cool thing here is that I can now start interacting with my note card right here. So I don't have to set anything else additional up. It's quite literally as easy as just screwing in a note card and then plugging things in, and you're good to go. Now, if I scroll down in this tutorial a little bit, the first command that this guide is going to have us do is run this card.version request. And what this shows is what the communication method looks like with Notecard. So Notecard is a system on module. The way you communicate it with it is you send it JSON. JSON is a spec that looks a little something like this, where you pass these quoted name value pairs. So in this case, a request named card.version. And then Notecard also responds with JSON. So in this case, card.version is just a way of getting metadata about your device. So this is version number. This is a cellular note card. It has GPS on it, various things about the device. Now, I'm showing off this tutorial in the browser, and that's how we recommend getting started because we think it is the easiest way to learn how Notecard works. But you can also send the same requests through a couple different other ways. So if I go into the tools and SDKs section of our docs, we have a command line interface you can use to communicate with Notecard. And then we also have a handful of firmware libraries as well. So the same requests that I'm going to be sending throughout this tutorial are requests you can also send in an Arduino app, just using C, Go, Python, or platforms like Zephyr as well. And I'll show an example of the Arduino one here at the end of this tutorial. All right, but we're going to start just in the browser. And we saw how to send a request and get a back and forth response with Notecard. But to do anything that involves actual data, your next step is to set up our cloud backend, and that is Notehub. So Notehub is a cloud. Got to get off to my main page. Notehub is available at notehub.io. It's our cloud backend that Notecard knows how to talk to out of the box. And the first thing you have to do is set up a free account on Notehub and then create a project. And we'll call this one July webinar and go ahead and create this. Now, projects in Notehub are just logical ways of grouping your devices, your configuration settings, environment variables, things like that. And to start, all I need to do is get an identifier. Because Notecard knows how to speak with Notehub and only Notehub out of the box, the thing it needs to know to set up the actual communication to get in that 2 lines of JSON that Rob showed in his slides is this identifier, which we call a product UID. And if I go back to my tutorial and I scroll down, you'll see it's telling me to copy that product UID because the next request I need to run is this hub.set request. Hub.set is what associates the actual physical device that's sitting on my desk with my cloud backend project in Notehub. It also has some other settings that we'll look at later on related to exactly how Notecard makes that configuration, because you can either have Notecard maintain a continuous connection to the backend, you could make it more of a low power device that connects periodically, and you can do kind of everywhere in between. But for now, all we're going to do is we're going to make the simple association. We're going to tell the device on my desk that this is the cloud backend to use. And by default, that doesn't do anything because the Notecard, by its default settings, acts as a queue. You queue up data or changes or whatever on the device. You can also queue up data and changes on the cloud as well. And then at intervals you specify, those changes will be synchronized. So the Notecard will take any data or stuff that it has locally and push it up to the cloud. And then it'll check on the cloud to see, is there anything up there that I need to pull down onto the device? So you can configure those intervals, or if you want to keep things simple, or if you're running a demo and really want to keep things simple, you can run this hub.sync request, which basically just says synchronize all local changes and all cloud changes. Now, in this case, the only change that is queued is just this product, this association of the product on my device up with the cloud. And so what this should do as soon as I sync is, and I had the status, it looks like, turned off there, is just start a cellular connection. So this is a Notecard cellular that I have connected. And what this is going to do is it's going to fire up the modem. You'll see that's what it's doing here. And it's going to synchronize that change with the cloud. Looks like it's doing it now. The cool thing is that you'll note that the stuff that I didn't do, so I didn't mess with a SIM. This is a Notecard that's just basically straight out of the box. I didn't have to sign up for any cellular plan or anything like that. I didn't have to configure a modem at all. Really, all I did was run one command. And then if I go back to my cloud backend and refresh, you'll see that I made that connection. And it really is that simple. That is the 2 lines of JSON right there just to get my device configured. And now it is on the cloud. And then once you have this connection established, that's really where the fun begins, because now that you have a connection to the cloud, you can start sending your data, pushing up data, pushing down data if you want to build a smart homey type of thing where you control something. All of that is now possible. And Notecard provides a number of APIs to help you do that. The easiest one, and the one that is shown next in this tutorial, is the note.add request. This is a request that takes a body argument, and that body can be whatever. So in here, you could put your sensor readings, whatever data you have that you want to send to the cloud. With this example, we're basically mocking a temperature and humidity sensor. And actually, our next tutorial will show how to make this use real data. But for now, just to show how this works, we will queue up this data onto our Notecard. And again, because Notecard acts as a queue, just because I queue data doesn't mean anything actually happens. To do so, I have to wait to my configured intervals, or again, just run a hub.sync request, which is again going to synchronize all local and cloud changes on the device. So this is again going to fire up the modem. Notecard is connected periodically by default, so it doesn't maintain that connection. I could switch my mode of my Notecard if I wanted to, but in this case, the connection is going to be pretty fast. So it's establishing a new connection. And then what's going to happen is this data that I queued up over here, this temperature and humidity data, once it synchronizes, it's going to appear on my events list. And it looks like it's doing that right now. It's pushing, yeah, I just saw that it was pushing up data.qo. So I have that, and here is my temperature and humidity coming through on this data.qo note file. And when I go into this event, if I go into the JSON, you can see a bunch of additional metadata that Notecard captures. In addition to the actual data itself, so here's the actual temperature and humidity that we're using. You'll see Notecard creates various identifiers for you and also captures things like, in this case, the tower location. So this is the tower that handled my request. If I enable GPS on this device, so all cellular and Wi-Fi based well, all cellular-based note cards have GPS modules on them. And if you enable that, you could also get GPS readings that are associated with your the actual data that you push up. For Wi-Fi based note cards, you can get Wi-Fi triangulated locations that you can push up with your devices as well. And then in addition, the session data. So when I have sessions opened in here, so Notecard establishes what we call a session every time there's a new connection established between a Notecard and Notehub. And there's also some different metadata in here as well, like the type of connections. This was done over LTE, my signal strength, the voltage of my device. Notecard's got a temperature thing built into it, the orientation of the device, whether it has USB power, the last time it moved. So some other really interesting data that you just get for free by using Notecard. And really, that's kind of the cool thing overall is that it really was just what a handful. You could see our full thing here, right? We did hub.set, hub.sync, node.add, hub.sync. And without any other setup, we have a cloud connected device. And at this point, we could start customizing it for whatever product we want to build.
No,
I think yeah,
I
go ahead,
didn't,
Rob.
I just want to be clear. I didn't lie to everyone earlier. So what you can do is just the hub.set, skip the hub.sync, and then do the note.add command with a an additional parameter that's called sync. And so then you can
Yep.
do, instead of those four, you can do two. So those are my two requests.
You can do too. I made it a little more verbose to just to follow the tutorial flow. The and actually the last thing I'll mention because I meant to mention this as well is so I'm only showing off one way data flow. One way being I took basically a temperature reading that was from my device and pushed it up to the cloud, but I can also push data back down as well. So I can add data in this direction if I wanted to say, light status on, and if I wanted to push that down and use no card with a host to control, say, a light bulb, that's something I could do using this mechanism. And also, probably one of our more powerful settings is we have this concept of environment variables that are a part of Notehub and Notecard as well. So you can take configuration settings and sync them across your devices and fleets of devices. And it's a really powerful mechanism for pushing device or pushing data down from the cloud down to your devices as well. But I want to go back to our tutorial flow. So I'm going to go back to our list. So that is the Notecard Quick Start that just teaches you the basics of how to set up a note card, how to use it to send data to the cloud. The next tutorial, configuring the Blue Swan, I am going to skip over because I've already got that established. It's pretty easy to do. It's just about talking about how you can send firmware over to the device. Our third tutorial is on actually building an app. So taking the different components of our starter kit, putting them together and starting to build something real. And if you look in this tutorial, we also let you configure this a little bit depending on the ecosystem you're using. So the defaults here are the components of our starter kit, but later on, if you wanted to see how to use like a different note carrier or a different microcontroller alongside Notecard, that's something you can do through this tutorial as well. But what the default flow is going to teach you how to do is write firmware for the Swan. So some Arduino firmware for the Swan that basically builds a mini project that acts as a temperature monitor. And what I'm going to do is we're going to fast forward to the end. We just completed the tutorial, so congratulations, everybody. And I'm going to bring over the final state of this over here. And if you're not a C person or really familiar with C code, don't worry too much about understanding every detail of this. And I'll actually blow it up here a little bit. All I really want to show you is that the steps I'm taking in firmware here are pretty much exactly what we did in the browser. So if I scroll down, you'll see there is this hub.set request. So the same thing we ran in the browser. In this case, I am setting this to continuous mode because this is a demo. I want data to sync pretty quickly. So I'm going to let this note card have a continuous connection. I'm configuring an inbound and outbound. So when I mentioned earlier, you can configure intervals on Notecard for how often to synchronize data. It's through these inbound and outbound properties. So if this were, say, an air quality monitor that I was putting outside and I wanted data to sync every 30 minutes, this is the configuration I could build to do this. In this case, though, Rob mentioned this earlier, but later on I'm using this sync flag because Again, this is a demo, so I'm not building low power friendly for a demo. I want to see my data as quickly as possible. And this is using that second request that we ran, this note.add request. So the full flow here is we get into our firmware, we run that hub.set to act as configuration. And then in Arduino's loop function, which basically just runs continuously, we take a temperature and humidity sensor reading. We log it out. That's what you're seeing down over here. We queue it up on our note card. And then we could leave it on the queue, but in this case for a demo, we're using this flag to sync that change immediately. And it looks like it's syncing well because this the response here tells me how many notes are queued. And as long as this total doesn't go up, you know those changes are being sent over to Notehub. And so what I can do is return to my browser. And this is a different project. This is my weather project. And if I go into my events view, you'll see the readings that are coming through. I think I have it set up every 15 seconds, and it looks like they're every 15 seconds. Usually it gets hotter in my room as this goes. You can see the temperature going up a little bit as we go through this. So that's the basics of how to send, basically how to build something that's a little more real with Notecard. So instead of just hard coding commands in the web terminal over here, instead we're building actual firmware. So something that more resembles like what you might build in a production scenario. And again, we're offering sort of opinionated ways to get started so you can kind of see the full picture of what building with Notecard looks like. But when you get ready to build your own product, especially at scale, you can start to substitute in different hosts or different note carriers or even your own custom note carriers, different note cards. You can kind of play around with the variables to tailor it to whatever you want to build. And that actually brings me to the last part of this tutorial flow, and that is what to do with your data. So Notecard makes it easy to capture data, to get data into the cloud, but you probably want your data ultimately someplace that's not this table view in Notehub. I mean, it is a pretty nice table. It's nice to scroll through, but you probably either want to get this to say like your own database or maybe your own cloud platform. Maybe you want to get this into a spreadsheet. There's a lot of things that you might want to do with that. And that's what routing in Notehub is all about. So in Notehub, we have this mechanism for routing data. So basically, as data comes into Notehub, it can be sent, and you can configure exactly how it's sent to other different platforms. So those platforms can be just a general, like if you want to just make a general HTTP or MQTT request, that's something that's possible. Or we'll offer more optimized connections to some of the big clouds, the AWSs, the Azures, the Google Clouds, those sorts of things, as well as some specific dashboarding platforms, Datacake, Blink, UbiDots. There's a bunch of other those as well. And we'll help you get those data, your data really to any of those where you ultimately want it to end up. Now for this, and I should mention too, for this tutorial, this dropdown just lets you configure how the tutorial flows. So if you have one of those platforms, our tutorial will walk you step by step through it, hopefully with the platform that you want to use. Now, the one I'm using for today is a route I already got it set up for Datacake. So Datacake is a really lightweight dashboarding platform we like using because it makes it really easy to build simple charts and graphs for your projects. And I have a Datacake route that is already configured. Really, the other reason we like using it is the configuration is as easy as just giving them a URL and sending all data over to them. And so then what ends up happening is if I go to my events, so data that's flowing into my project, you'll see that I have this green check mark next to each event saying that this data was routed successfully. So if I take this reading in particular and go into it and go to the route log, as this data came in, it was forwarded to Datacake. Datacake said thanks, which was nice of them, and gave us a 200 response. And so the last tab I have open is a little Datacake dashboard that I built. So this is a pretty simple dashboard. All I'm doing is showing the temperature, humidity, and voltage, the current reading of it. And I've got a little chart where I just show the data over time. So the temperature has been going up, but just a little bit here in my office, and the voltage hasn't really changed because I have this thing plugged in. But overall, just what I wanted to show is how easy it is to connect your data from Notehub to a different platform. So this is a really simple example just to show how to get your data into to Datacake. But regardless of the platform, Notecard and Notehub make it pretty easy to get your data wherever you want it to go, especially when you compare it to the process of building all of this stuff manually, from the hardware to the cloud architecture and everything in between. And Rob, that is the end of the flow. And we kind of showed the full picture. So going from setting up your note card to setting up a microcontroller, having your microcontroller work with note card to build more of a realish project, and then ultimately getting your data where you want it to go. Now, there is a lot more detail we can go into for all of these topics. The starter kit is very much intended to show the happy path through using our tech, but I think that's a pretty decent intro. What questions do we have? I think I'll toss it back over to you.
Yeah, that's great. We do have some good questions. I want to just wrap up my slides really quickly here if we can. So I'm
Yeah,
gonna
I'll take me down.
replace TJ here, but first, oh, you already unspotlighted yourself. All right, let's everyone see TJ's picture again. There we go. Um, my slides don't want to move, of course. It's strange. There we go. All right.
You're good.
Well, let's wrap up here with what I call the most important slide. And I say that because for Blues to be successful, of course, we need to demonstrate the value that we think we provide. And these are what I consider like the biggest differentiators, I suppose, in the industry for us. So as it says here, I feel like we provide the easiest onboarding path for wireless connectivity, full stop. I think you kind of saw that from TJ's presentation as well. You can deploy with different RATs, different radio access technologies without changing your code or your hardware, right? Because you can swap in different note cards. The note cards all share the same physical connector and the same developer APIs, which I've probably said like 5 times now. But when looking at 5G satellite, you don't want to be caught in the inevitable 4G sunset, for instance, without a path going forward. And Blues is thinking along those same lines, right? In terms of having that same form factor, leveraging that same no card footprint and API for future technologies. And everything we develop, again, is low power by design. Said it before, I'll say it again. Cellular, the no card cellular only consumes 8 microamps when idle. And finally, when looking at the future, even if Blues were to go out of business, which we're not, you're not stuck, right? The 10 years of cellular service that you get does not go away. Your device can actually still function without Blues. So it's kind of a no-brainer for me. Last thing I want to mention is that Blues also offers numerous example apps that range from fully built reference applications all the way down to very targeted code samples. They're all free, they're all open source. They showcase a variety of best practices as well to use when using Notecard and Notehub. You can clone them, use them as you want. You can find all those at dev.blues.com/example-apps. Now, before we jump into some of the Q&A, just want to leave you all with some resources here. So dev.blues.com is where you're going to find all of our technical resources, our documentation, the web serial terminal as well. And shop.blues.com is where you'll find our starter kit. So we have a global starter kit for $99 that includes a note card, Notecarrier F, and a Swan host microcontroller. And what's the last one on here? Oh, our forum, of course. So if you have any follow-up questions after this webinar, feel free to use our forum at discuss.blues.com. And with that, how about some questions? So, all right.
Well, while Rob's filling with the slides, we
Got
had
it.
one really good question from Tobias about latency, like how much latency is there involved on, say, like a no card cellular and also no card Wi-Fi. Wi-Fi is going to be pretty fast. There's always going to be some latency involved, but it's going to feel pretty instantaneous. Cellular is harder though because there's a lot of different variables involved when it comes to cellular. So we make different cellular note cards depend for different cellular bands and different cellular technologies. So we have wideband note cards, midband note cards, and narrowband note cards. If you're really going for low latency, you're definitely going to want to go with our wideband note cards because they're going to offer the best connectivity, the least latency, those sorts of things. But there is still some variance depending on how far you are from a tower because we are still communicating over cellular. So there's how good your signal strength is will also factor into it as well. I can say that from my own testing, I have latency when I configure Notecard to get basically the fastest responses possible. It takes about, a second, second and a half sort of to get the fastest possible requests to my device. Cellular through, low power cellular is never going to be as fast as Wi-Fi, but we feel we're pretty snappy when you have things configured in, say, continuous mode, synchronizing right away. You can get it reasonably fast.
Yeah, perfect. Scrolling through some of the questions we had, we did get a couple questions about satellite, specifically our StarNote product, and we didn't talk about it too much in this webinar. But just so you know, we do have a satellite IoT product that's called StarNote, and it acts as a fallback option. So if you're deploying a product that uses cellular or Wi-Fi primarily, and either cellular or Wi-Fi goes out entirely, Notecard is smart enough to intelligently flip over to use satellite. Our StarNote product, I can't quote the exact price, but it's very reasonable and ships with 18 kilobytes of data prepaid. That may not sound like very much, but considering the type of data you should be sending with it, you can actually use, I think the estimate is 50 bytes per day will last you a year. I think that's our marketing line for it at least. So
Yep.
yeah, lots of cool capabilities are kind of unleashed with satellite as well. Um,
Yeah, we had a related question come in about how the flow I showed would differ if I wasn't using cellular. So all the examples I was showing were using a cellular no card. If you were using Wi-Fi, there'd just be one additional request to run. It's a card.wi-fi request you run on Notecard, and essentially you just have to tell it the SSID and password of your Wi-Fi network, and then everything else is the same. So it really, our APIs are really agnostic. With LoRa, there'd be two things that would be a little bit different. First, you'd have to have a LoRaWAN gateway. So the way LoRa works is you speak with LoRa over a gateway. I've got one in the corner here. If you buy our our LoRaWAN starter kit, it comes with a LoRaWAN gateway, so you'll be all set out of the box. And then you also have to configure what we call a note template with LoRa. Because LoRa is a really, really low bandwidth protocol, we require you to tell us about the type of data. So the only change that you would need to make is when we had those note.adds where you're adding temperature and humidity, there's one additional request called note.template where you have to tell it about the data types for temp and humidity. So you have to tell Notecard temperature is a 4-byte float and humidity is a 4-byte float. And then from that point forward, everything else is identical. And those templates also work on cellular and Wi-Fi. So you really truly can build firmware that just runs regardless of what node card you plug in.
yeah, perfect. Lots of questions coming in here today. I know we're going to miss something here, but a question came in a little bit earlier. What are the Blues' strengths versus Particle and other similar companies? It's a great question. I'm definitely not here to bash on Particle. What's interesting is quite a few former Particle employees actually work at Blues. Um, what stands out for me and what generally resonates with people is that Blues is not going to dictate the microcontroller that you're using or the language, anything like that. We provide a pretty open ecosystem compared to Particle. That's probably number one. I don't know what the from there. I'm sure there's other differences, but that's kind of what stands out for me. And let's see, does Notecard support eSIM? So I think I know where this question is going. So we don't directly support eSIM, but if you need to use a separate SIM for your application, for your product, other than what is provided on the Notecard itself, you can use an external SIM as well, so a physical SIM, and you can actually switch back and forth between the two as connectivity comes in and out. If like you have like a tracking application, for instance, and it moves from country to country, and maybe like one big country that we can't support is India. So if you have that product going through India, you can have the Notecard intelligently switch over to use your external SIM while in India, and then back when it retains connectivity. So lots of options there as well.
And some of our note carriers have slots. Like I just grabbed the Notecarrier F, which has got a SIM, a slot for an external SIM, and like Rep said, all the APIs to manage those back and forth. You can even set up like which one's primary, which one's secondary. Like there's there's lots of APIs in to help cater for that.
And there's a question earlier, does Blues have an integration with Losant? And the answer is no, we don't have like a dedicated route template, if you will, for Losant. But I've personally used Losant a couple times just using our generic HTTPS route, and it works just fine. So
Yep,
definitely
same.
can work with Losant, absolutely just fine. Let's see, any other questions? Oh, a question about is the Blues LoRa kit LoRaWAN certified? I don't know the answer to that. That would be a good one to post on our forum at discuss.blues.com, and we'll find the answer for you. Um, with that, yeah. Sorry, I'm just
Yeah,
scrolling
there's
through what we
there's
have
one
here.
last question that came in too about like if I use a note card in my solutions, the current burst during
Oh,
startup affects my circuit. How do I cater for that? That's probably a good one for our forum as well because we can get into more detail there than we have time for here. I'll just say that we have details around that in our data sheet, so I would definitely start in the note card data sheet for whichever note card you have, because we get into details about the current spikes and how to handle those there.
yeah. Yeah, I mentioned this a couple times, but again, if you have any questions afterwards, feel free to post them on the developer forum. TJ and I are on there all the time, and if we don't know the answer to the question, we'll get somebody smarter than us to come in and help out as well. And with that, I think we can wrap things up. Thanks everyone for taking the time to attend. It's been great. Hit us up at discuss.blues.com, grab your starter kit, and yeah, we're excited to see what you all build with Blues.
Yeah, thanks everybody.